Today's Daily Dose of Math is part 3 in our series of videos about the sphere and the hemisphere. One of the ways that you can be asked to find the volume of a sphere or a hemisphere is, instead of being given the radius or even a diameter, you're given the area of the sphere or the hemisphere. You have to use the area formula to find the radius, then you can use that radius to find the volume. It just becomes a two-step process. One of the things that we need to look at is the difference between the total area of a sphere and the lateral area of a sphere. And that is to notice that there is no difference. The total area and lateral area mean the same thing when it's a sphere. So here is the total area formula, which is the same as the lateral area formula. It's 4 pi r squared. When we're dealing with a hemisphere, we alter the formula so that it's 2 pi r squared. We're not doing this because it's gone from total to lateral. Those formulas are the same. We're doing this because it's gone from sphere to hemisphere, and the area will be half as much. So we have a 2 instead of a 4. Let's do the first problem. We know that the total area, which is equal to the lateral area, of this sphere is 16 pi meters squared. So I'm replacing the A with 16 pi. I need to find the R. And I'm going to be able to do this because now R is the only variable in the equation. Now, why did I give it as 16 pi instead of some decimal? Because having that decimal would have required rounding. And that would have made my radius give me a decimal that is close to the real radius, but not right on. But there's another reason. To show the student not to be afraid of pi, not to always immediately replace it with 3.14 or 3.1416. Because what we're doing now is we're trying to isolate the R. And the first thing that I'm going to do is divide both sides by pi. And these are going to cancel. Now we don't have any pi in the equation at all. So we never did need to turn it into 3.14 or anything else. I'm also going to divide both sides by 4 because I want to cancel this 4. This 4 also cancels and the 16 turns into a 4. We now have nothing left on the left side except a 4 and r squared on the right side. So we're nearly finished. We square root both sides and r is equal to the square root of 4, which is 2. It was meters squared, so that will be 2 meters. I'll draw a line here to separate my two problems. Now we can use that r in this formula. The volume is going to be equal to 4/3 times pi times 2 cubed, which is 4/3 times pi times 8. We have 32/3 pi. And that is actually a correct final answer. But if I want it in decimal mode, 32 divided by 3 times pi is, I have 33.5 if I round to the nearest tenth. 33.5 meters cubed. I'm finished with the top problem. Now the bottom problem is the same thing, except it is a hemisphere instead of a sphere. As we know, the lateral area, total area, doesn't matter. The area is the same. So we have area equals 2 pi r squared, and we know that that area is 18 pi. I'm going to divide both sides by 2 pi. I'm doing it all at once here. These 2's cancel, these pi's cancel, these pi's cancel, and 18 divided by 2 is 9. I have 9 equals r squared, so r is equal to the square root of 9, which is 3. This was, oh, I didn't give a unit, so I'm going to put one now, centimeters squared. Therefore, my radius is 3 centimeters. And I can plug that radius in here. The volume is 2/3 times pi times 3 cubed, which is 2/3 times pi times 27. The 27 and the 3 will cancel, leaving a 9. So I have 2 times 9, which is 18 pi. And if I want decimal mode, that's going to be equal to 18 times pi, 56.5. We had centimeters, so this is going to be centimeters cubed as my final volume. This is how we deal with the extra step that is required when, instead of being handed the radius or a diameter for a sphere or a hemisphere, we're given an area instead. That is today's Daily Dose of Math. Please like, subscribe, and share.